showing how to use a library called PySTAC to create static STAC catalogs. So I put together this notebook yesterday. So apologies if there's any errors. It's up on the docs site. So first off, I'll just show pystac.readdocs.io has a bunch of documentation. It has a quick start, concepts about reading and writing, various aspects of using PySTAC. It also has tutorials that are encoded in Jupyter notebooks that you can look at on GitHub, or we're using an extension of the Sphinx to actually render the notebooks in the documentation. And then this tutorial is already up here, right? So you can check it out on the GitHub or in the rendered document form. I'm running a local version of this, so we'll just go through it step by step. Great. So PySTAC is a Python library that supplies these core types, right? Chris was talking about items, collections, catalogs, these types of things. So PySTAC just provides those as core Python types, and it aims to be basically zero dependency. Datetime util is not part of the standard library, unfortunately, so it's in there. But otherwise, try not to have any dependencies. So anything you do with the stack items, using REST area or Shapely, you'll have to kind of do that. So this notebook just makes sure that Boto 3 for reading off of AWS and REST area and Shapely for working with rasters and vectors is installed. And then it's still a very new library, so I'm not sure exactly how I want to use it. I really like the NumPy thing if you just import something and then you just do dot notation off of that. But ST doesn't really work, so I imported PySTAC as stack and saved a glorious 2 characters. But yeah, so let's run through creating a catalog from a local file, right? So we're going to be working with a SpaceNet 5 image. SpaceNet, which is run by In-Q-Tel, Cosmic Work of thank you. In-Q-Tel is a set of open data sets and machine learning challenges. SpaceNet 5 is around trying to predict speeds of road networks. And it's still going on. So you have 3 days and 11 hours to win $20,000. But we're just going to grab, so they host the data on a publicly accessible AWS bucket. So we're going to just grab one locally and store it in a temporary directory, right? So let's create a catalog, right? And then so one of the nice things, it's a little bit difficult to kind of flip back and forth from a GitHub markdown spec to figure out, okay, what are the things that I need to satisfy the constraints of whatever catalog is, and then write the Python code. So we have Python docs that will kind of say what you need to supply in order to create this object, right? So it's sort of encodes the spec for you, so you can just kind of work with Python objects. So catalogs are really simple. All that's required is an ID and a description, which we supply here. As you can see, we can try to access children and items. Children are sub-catalogs and collections that are contained by this catalog. And items are stack items. We don't have anything, right? So let's create an item that represents that image that we just downloaded. So you can see from the PyDocs that you need an ID, you need a geometry, which defines the full footprint of the asset that fits to a GeoJSON polygon. Or I believe that you can also do a multi-polygon. Then there's a bounding box, which can represent a 2D or 3D geometry. If it's 2D, it's just the, X min, Y min, X max, Y max. And you need a date time since it is a spatiotemporal asset. You also need to define some properties, although this can be an empty dictionary. So one thing that we found useful is just to like pull the bounding box and the footprint out of raster data with rastereo. So we'll read that from the metadata, the geotiff, and then create a bounding box and footprint for this raster. If the footprint, like, so for instance, like, Landsat image has, a tilt to it and a bunch of node data surrounding it. So in that case, like a footprint really should be the polygon around the data value, like the actual scene. But in our case, we're working with like a pretty small image, and there's, I don't believe there's any node data in it. One thing that I've found is that, sometimes you just don't have a date time for your STAC item. So I end up using UTC now a lot. That's not necessarily the best workaround, but it's a workaround. Ideally, if we're representing, satellite images, we'll include the capture date, etc. So right now, the item's parent, we just created this bare item. The parent is none. STAC catalogs are linked together. Both like the catalog will link to an item, and item will link back to the parent. So once we add the item to the catalog, we can see that the parent was correctly set. There is a describe method on catalog that just loops through, like crawls the catalog and then just prints out sort of an a console version of the catalog, just so that you can kind of check what you're doing as you go. Don't call this on like the Landsat stack, because it'll actually try to crawl all that and it'll take a long time. So items are nothing without assets, right? We created an item to represent our image, but we haven't added the asset, which is the geotiff, right? An item is just a collection of assets. The assets are the actual files that we're basically cataloging. So an asset includes an href to the in our case image, an optional title, an optional media type, which will allow you to say, oh, this is a geotiff, or this is JSON. And then there's optionally some properties that extensions can use to enrich assets with additional information. We'll see a little bit later that an Earth observation asset includes band information, which describes what the bands that they represent are. So here we're just kind of in one line creating the asset from the image path, and then saying that it's a geotiff. There's a media type class that just holds a number of the common media types that are listed in the STAC spec markdown pages, just for easy access. You don't have to remember the media type definitions for those, but that just evaluates to a string. And then an asset in an item is a dictionary, so we have to give it a key. Image seems appropriate. Go for it. Sure.
Is an item the same as an asset?
No, so an item, let's do this. So an item to dict. Now that I've hold on. Let me actually make that a little nicer. Print JSON dumps and then equals 4. So an item is what envelopes an asset, right? So an item represents the sort of the a snapshot in time of Earth. And so that can contain several assets. So if you were collecting, so for instance, Landsat has geotiffs for each of the bands. And so each of those would be an asset. So band 02 would be an asset contained by the item, which is the scene.
That's if you had them different chips. You could have all these things in one chip.
Totally. Yeah. And so you can have an item that only contains a single asset. This just allows you to sort of describe that footprint in with multiple assets. And then so another asset that is strongly recommended to include by STAC is the thumbnail. So you can have a key named thumbnail that, something like STAC browser will look for that asset that says thumbnail and use that as the thumbnail. I did exactly that. That's funny. So that's that. Yeah, so we can see now that our assets have this image key and we have an href, right? We also have the bounding box and the GeoJSON geometry. So it's a feature, right? It's a GeoJSON feature. Note now that the hrefs are nulls. That's because we haven't said anything about where these files are located. So with PySTAC, you can build up stacks in memory and link them all together like through the links like the Python objects, and then all at once say, okay, set yourself to this route, and then it'll spider through and set all of the hrefs appropriately. So let's do that now. So like I mentioned, the get self href is something that you can call in a stack object that just gets that sort of the file location. And if it's none, that means it hasn't been set. So there's a method on catalog called normalize hrefs, which takes in a root, like a root directory, and then normalizes all of the hrefs for all of the catalogs, subcatalogs, collections, items, etc., based on the best practices documents that describes like how you should lay out a catalog. Here, I'll click on that. So this best practices document, one of the things about PySTAC is that I tried to like just include as much of the best practices in PySTAC so that it kind of by default just like follows the best practice. Like stack catalogs don't need to be laid out a certain way, but if you're creating one from scratch, it's good to just follow this practice. And then so with PySTAC, you can kind of just do that without thinking about it. Yeah, so these normalized hrefs we do to our temporary directory, and now we see that the root catalog is under the stack directory that we laid out, and then the item is according to the item ID, a folder in the item ID, and then the item ID again .json as the best practices state. So now with that, we can save it. Now, you have to give a catalog type when you save it. And the reason for this is that stacks can have links that are relative. They can also have links that are absolute. And it gets really tricky if you don't kind of just like follow the standard way of formatting all of the links. So this again follows the best practices document. So the best practices talks about the use of links. There's self-contained catalogs. So self-contained catalogs have links that are all relative. Everything is relative. Now, notice I'm talking about links and not assets. They're two different things, right? A link is a way to link to another stack object. An asset is like a file that's contained by the item. So you might have absolute links to your assets because they live, somewhere on the internet. But your catalog is totally self-contained. It's all relative links. You can copy it around, and none of the links are broken because it's all self-referential. That's great for catalogs that you want to sort of have that portability, right? For published catalogs, it's recommended to do one of two things. Have the root of the catalog have a self link, which is the absolute link to where you got like the published catalog. That way you can track where the data came from, right? So if I grab all of a stack that's published somewhere, now it lives on my file system, it'd be nice to keep track of where that thing came from, right? One thing to mention is that self-links are required to be absolute. So self-links can't be relative. So in the self-contained catalog, it just doesn't contain any self-links. It's just, you know, none of the objects describe themselves. It just doesn't happen. Within relative published catalog, and this might be getting like really into the weeds, you know, you can read this a bit on your own time, so I'll go through this quickly. Relative published catalog is one where the root has a self-link that points to the published location, and everything else has no self-links and all relative paths. And an absolute published catalog is everything is absolute hrefs, right? Everything is absolute links, which is sort of like preferred because it allows for the most you know, traceability of where things came from, but they're really hard to copy around. You know, you want to manipulate a STAC catalog, and all of a sudden you have to like fix every single link in it. They're kind of annoying to work with. I point in here to the API docs. Unfortunately, like you can't do like a help on attribute PyDocs, but anyway, so the catalog type kind of like gives you sort of a cheat sheet of like what these things mean, and point to the best practices document about what each of those mean. So here we save it as a self-contained, right? So all the links will be saved as relative links and no self links. And then if we just list this directory, we can see that we created this catalog and then this local image.json. We can open up the catalog, just read it in and print it out to see that everything is as it should be. Right, we have the root, we have the parent, and no self-link. If we were to save it as an absolute published catalog, now everything is, now everything has absolute hrefs and there's a self-link. The asset hrefs, right, are in both of those cases are absolute because again, like it's kind of a different thing, but you can, so in a truly self-contained catalog that you can make portable and make copies of, you have the assets sort of like in the item folder that it belongs to, in which case you can use the make all assets asset hrefs relative to then give the assets relative links. And now you have like a completely copyable stack. Any questions so far? Sweet. All right. So we talked a little bit about extensions. That's a page not found. That's good. My my Apple keyboard is awful, so it just pastes things twice. EO is an example of an extension that includes additional item metadata that is common for Earth observation data, right? Like ground sample distance, what platform it came from, etc. So we've encoded this as a subtype of item. And once again, you can kind of print out the PyDocs to see, okay, in addition to what I needed for the item, I also need a ground sample distance, a platform, an instrument, and a list of bands. Everything else is optional. So here I create some bands that are defined by the EO extension, give them some common names, and this is just based off of the Worldview 3 documentation. And now I can create an item that is an EO item that includes this band information. I'll add an EO asset. Like I had mentioned, assets can have additional properties, so extensions can use them. And so this actually lists out the bands that this asset applies to. So in the case where there's just a single image and it has bands 0 through 8, you just have to list out the indexes to the item's band list that this applies to. So go I can clear out the items in the catalog and then add my Earth observation item and then save it again and see that if I read the catalog back in, so this catalog from file will just read in the catalog, I can get the items and see that I have an Earth observation item. And also I have an Earth observation asset. And then the dictionary and the JSON encoding of the Earth observation item has all of the Earth observation data. Great. On the collections. So as Chris mentioned, collections are a subtype of catalog that sort of represent like, oh, these are all from the same sensor, or these are all sort of from the same area. We use collections when we're putting together stacks of machine learning data. If we have a bunch of different areas, we'll have a collection represent like the images and label data of a specific area. One of the tricky things about collections is, tricky at least to encode in the library, is that if you have an item that belongs to a collection, or a set of items that belong to a collection, common properties of the item can live in the collection. So when you're looking at an item and you're trying to get information about it, you can't just look at the item's properties, but you have to look at the properties of the collection that they are a part of, because it can contain properties that describe the item. And we'll go through an example of that here. So in this case, I'm downloading another image from the Moscow area for the training data of SpaceNet 5. I get the bounding box of footprint. And I want to create a collection that stores those items and then also contains the common metadata between those items. So a collection here, right, we need to provide it this extent, which is the trickiest part. And then, like I said, it also has properties that you can provide that are common across the different items. So an extent of a collection is both a spatial and a temporal extent. So it defines like the dimensions of the collection, and that's useful for if you want to do, with the STAC API when they're indexing this stuff, if you want to search by collection instead of by item, you can, or even if you were searching by item, you can check the collection's dimensions to see if they intersect with your query bounding box or time interval. And if not, you could just avoid working through all of the items in that collection. So what we found to be useful is that, okay, so here I'm just creating new items that represent the two images. Notice that I'm creating an item like a plain item, and I'm saying that it extends EO. This is because I can't create an EO item if I'm not going to supply like the ground sample distance, because that's a required property for an EO item. But I can just treat it as a regular item and then store the EO data in the collection as a shared property, right? So I still can use like an EO asset and then declare this as extending the EO stack extension, which will make more sense in a second. So I create those two items. And then here I'm just using Shapely to union the footprints of my items to just create to figure out the extent of the collection. And then I set that as the spatial extent, which you can have more than one bounding box in a spatial extent. So it's a list of bounding boxes. And then I just sort the date times of my items to get the interval, and then set that into my temporal extent, and then I set those into my extent, and now I have my collection extent. Straightforward. So the common properties I'm going to store with my collection are the bands, the ground sample distance, the platform, and the instrument. All of the Earth observation data, because it's common across my items. And here I create my collection containing the extent and the common properties. Now I add these items to this collection. And I add this collection to the catalog. So now my catalog structure looks like this. I have the top level catalog, which contains a collection, which contains 2 items. Right? And notice these are regular items, not Earth observation items. If I go ahead and save this to another location, we can see that the collection has the Earth, I'm sorry. So this is the item. It does not have any Earth observation properties. However, if I read this stack from file, right? So I'm just reading the top level catalog. It actually reads these as Earth observation items because it recognizes that those items extend EO and their collection has the necessary information to make them into Earth observation items. So I can use catalog get all items to collect the items and then look at the bands of the first item, right? Any questions about that? The collection inheritance is a bit tricky. One of the things that's outstanding with PySTAC is to figure out how to write. It's like if I have a bunch of items in a collection and I want to merge common properties up to that collection, there's not really an API for that yet. So that's something that I'll be working on. But yeah, any questions about the collection stuff? Yes.
The catalog is one single JSON file.
Yeah. The catalog, the stack is basically a directory structure of multiple files. Yeah. The catalog is the top level thing that has links to those other JSON files that represent the collection and the items, etc. There is such a thing as a single file stack, which is an extension, which deals with item collections. So an item collection in Stack, which PySTAC has, is kind of like a feature collection of items that are sort of independent. If you have like a search search result, and you want to just stuff items into a feature collection, send it off. That's an item collection.
Because an item isn't a feature.
Yes, exactly. And then a single file stack is just an item collection, but also has a property called collections, which contains the JSON for all the collections that are referenced by those items. So if you're iterating through the feature collection and you see an item says I'm in collection, ID whatever, the single file stack will have that in its collections property. So it kind of just ties everything together in one big file, which is kind of nice if you're working with smaller catalogs. Matt Hansen wrote that spec, so he would know better the use cases. I haven't used it yet.
Are there extensions that try and cover things like uncertainties or accuracies in the data?
No, but that would be a good one to add. Sorry, there's the meeting thing in my way. How do I move this thing? Go away. Okay. Yeah, all of the extensions are in this extensions folder. So just to quickly go through them, there's not that many. Asset adds collection assets, which are just like assets on collections that don't necessarily represent like a single file. Checksum provides a checksum for items. Data cube is the one that does the sort of, has a dimension property that defines like the different dimensions of the data cube. There's a datetime range that adds just a start and an end to an item if your items span something. EO, which we just created, an EO item. Label, which we'll get to in a little bit. Point cloud is for the point cloud data, which is one of the sort of newer ones. There's one called scientific that's for putting in citations, like DOI information. SAR is for SAR data, and then here's that single file stack extension that we talked about, right? So they're all just listed there. And yeah, new ones are being added, and it's sort of an active area. So That's a great one. You know, I've been just pretty liberal about like opening issues on GitHub of just like, hey, is this extension worthwhile? And then usually there's a conversation around it. So people are pretty active about trying to consider all the different use cases. So that's what it's just. So it looks like I'm running out of time. So the rest of this, yeah, I only have 3 minutes left. So the rest of this is just to kind of use the concepts above to create a larger catalog of SpaceNet 5 data. I both create imagery items and then the label items, which are the label extension, which are for machine learning data. Two things that I'll quickly note. Like I said, PySTAC tries to be zero dependency. So if you want to read from S3, you're going to have to supply the mechanism to do so. But it provides a hook in a thing called STAC.io that allows you to define your own read text method and write text method, because all we're doing is reading and writing JSON. So, you know, here I just say, okay, if it's S3, then use Bodo to read it. If not, then use the default, right? And in this case, you just write it out if it's S3, et cetera. So it just provides a nice hook for you to like whatever, you know, mechanism you want to read and write with, you can just kind of hook into your the start of your script or the init of your client library. So just wanted to mention that. So yeah, this goes through and just is like, you know, more realistic example. We don't download the images. We just like to use the S3 URIs. And then right, there's this label item, which is an extension for representing either GeoJSON or raster labeled data for machine learning data. And yeah, you can take a look. Like I said, the all of this is on the PySTAC docs in the tutorials. That's the stable. We'll go to latest. Bada bing. All right, and you can check it out there. Any questions? We have a Gitter channel now, so go ahead and feel free to ping me. And yeah, any final questions?
I see how to create this catalog as PySTAC also starts making searching.
No, it does not. Yeah, it aims to be, you know, just the core types, like the static catalog types. I'm interested in this sprint to like figure out, you know, I wouldn't want to add stuff to PySTAC, right? I want to keep it simple. But is there something like PyGeo API or the stat search stuff that it can be integrated into that would provide that functionality on top of it and include more dependencies and things like that. So yeah, we're working. Matt Hansen said he was gonna rewrite stat search to use PySTAC and PySTAC search or something. So yeah, it's upcoming. Yeah.
I was kind of hoping that there would be some object-oriented library that handles STAC. Is that what this is?
Yes. For ingestion and reading static catalogs, like reading the files.
No, I mean, I like the Jupyter Notebook. I like being able to see it, and it's really helping me understand the thing that my team is implementing.
Awesome. Yeah, that's great. One of the things I want with PySTAC is like, yeah, reading through that Markdown spec and the JSON schemas is really difficult. But if it's in a Python library and you can kind of see how it works in an implementation, it's helped me understand the stack spec a lot better. So hopefully that does the same for other folks.
Speaking
Yeah.
of the stack spec, this is pedantic for sure, but I'm pretty sure the stack spec says every item is required to have some. But you said that for relative catalogs, they don't.
Yeah, I'm pretty sure it wouldn't.
Understand why they would.
It might have.
Maybe I'm out of date.
It might have been earlier.
Okay.
Yeah. Yeah, I think at some point it changed because they were considering relative, like at first Stack was all absolute paths, and then everybody was like, that's really annoying to work with. Because yeah, every time you copy a catalog, now you have to go through and change every link. So that's why it became optional. Cool. Are there any questions from remote folk?
Hi, this is Mike Kiley. Can you hear me?
Then let's get back to hacking. Woo! Thanks, everyone.